Welcome everybody. Welcome to my YouTube channel. My name is Aditya Maurya. Currently pursuing BE in Sri Venkateswara College of Engineering. My library number is 23CA1736. I'm currently in first semester, section day 1. Today we'll be discussing a small topic in the subject mechanical engineering. So the course code is BESCK104D. The course title is Introduction to Mechanical Engineering. The topic that I've chosen today is four-stroke diesel engine. Let's get into the topic and understand what is four-stroke diesel engine, how does it work, and how is the output delivered. As you can see, this is a simple working of a four-stroke diesel engine. The pistons moving up and down. There are certain things which happen during the movement of the pistons, and the outcome is shown here. This is the outcome coming out. The pistons here, the piston here, piston here, piston these, all these pistons moving up and down, up and down, up and down. These are all generating some form of energy that is in turn rotating the belt here, the output. The output is here, like okay. So let's get into this. Now we get to see a block diagram. We get to see a block diagram of how the diesel engine works. We get to see many stages. There are mainly 4 stages in working of the diesel engine. That is a suction stroke, the compression stroke, the working stroke, and the exhaust stroke. There are 4 certain stages in which the diesel engine works, through which the diesel engine works in order to give out energy. Let's get into this and understand and have a better understanding of the 4-stroke diesel engine. Okay, so first we have a suction stroke. Okay, so during this stroke, the piston moves from TDC, that is top dead center, to the bottom dead center. TDC is top dead center. Sorry, top dead center, and the BDC is bottom dead center. The inlet valve is open and exhaust valve is closed. The inlet valve is open, exhaust valve is closed. The crankshaft rotates by half a rotation and the piston moves downwards. The crankshaft rotates by half a rotation and the piston moves downwards. Suction is created in the cylinder. As a result, fresh air is drawn into the cylinder through the inlet valve. At the end of this stroke, the piston is in BDC. At the end, the piston is in BDC. At the start, it was in the TDC, the top dead center, and now it is in the bottom dead center. The cylinder is filled with air and inlet valve closes. Horizontal line. Okay, so the cylinder is filled with air and inlet valve closes. Now, after this is the next stage, that is the compression stroke. During this stroke, the piston moves from bottom dead center to the top dead center. The piston moves from bottom to the top dead center. Both the inlet valve, both the inlet valve and the exhaust valve, both are closed. The crankshaft rotates half a rotation, As the piston moves upward, the air in the cylinder will be compressed. The ratio is 16:1 to 22:1. The compression ratio in the diesel engine ranges from 16:1 to 22:1. Represents the PC curve with the PV diagram. As the air gets compressed, its pressure and temperature increases and attains a temperature greater than the ignition temperature of diesel. Diesel is sprayed into the cylinder through fuel injector. There are certain fuel injectors at certain points where the diesel is injected in the this thing, cylinder, and the high temperature of the air ignites the diesel. High temperature of the air ignites diesel as soon as it is sprayed and undergoes compression at constant pressure. Since the compression air ignites the diesel, this type of engine is called as compression ignition or CI engine. Due to the compression stroke that happens in this stage, it is called as compression ignition or CI stage. Now, let's get to the next stage, that is the working or the power stroke stage. During this stroke, the piston moves from TDC to VDC. Both the inlet valve and exhaust valves are closed. The crankshaft rotates by half a rotation. The high pressure of the burnt gases forces the piston downward, performing power stroke. The linear motion of the piston is converted to rotary motion of the crankshaft by connecting rod and a crank. It is represented by curve DE on the PV diagram. At the end of the stroke, the piston is in VDC. After the process and everything, the piston returns to the VDC, the bottom dead center. The exhaust valve opens, which releases the burnt gases to the atmosphere. This will bring pressure in cylinder to the atmospheric at constant volume, represented by line EB in the PV diagram. Now let's get to the next stage, what happens in the diesel engine. That is the exhaust stroke. Okay, so during this stroke, the piston moves from BDC, the piston moves from BDC to TDC. The inlet valve is closed and exhaust valve is open. The crankshaft rotates by half a rotation. As the piston moves towards the TDC, the burnt gases will be expelled out through the exhaust valve. So as we emphasize here, as the piston moves through the TDC, the burnt gases will be expelled out through the exhaust valve. When the piston reaches the TDC, the exhaust valve is closes and this completes the cycle. When the piston reaches the TDC, the top dead center, the exhaust valve closes and this completes the cycle. Okay, so in four-stroke engine, the four strokes constitute one cycle, hence the name four-stroke cycle engine. The crankshaft makes two revolutions to complete one cycle. The power is developed in every alternate revolution of the crankshaft. Four-stroke diesel engine produces higher power than four-stroke petrol engine. We can emphasize here that four-stroke diesel engine produces higher energy, higher power than the four-stroke petrol engine. This basically says that the four-stroke diesel engine is much more efficient than the four-stroke petrol engine. And now if we see the working, we get to the working, this is how it works. You can see all the torque. This is the okay, so this is the top dead center, this is the bottom dead center, and the pistons moving up and down, up and down. You could say this is suction stroke, the compression, the working, and the exhaust stroke, the final stage. All this comprises, all this work together to produce energy and hence the output. So that's it for today's video. I hope you guys understood what I wanted to make you understand. Yeah, so make sure that you like the video, comment, and do let me know that how was the video. So thank you.